Hola, 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 probando, uno, dos. ¿Cómo están mis estimados aprendices? Espero que estén todo bien, todo solo, wow, solo 11 alumnos tenemos el día de hoy. ¿Qué pasó con el resto?
Mister, aquí tengo a Marlon Calix, Ian Matamala, Valeria Martínez, Sofía Omana, Daniel Soto, Eduardo Hernández y Camila Berlíos.
Okay, thanks for letting me know, Mrs. Sue. All right, guys, welcome everyone. Please, the rest of the people at home, please turn on the camera. Thank you so much, Sophia, David, thank you so much, Camila, Ana, thank you, Ivan. Please turn the camera. Salvador, please turn on the camera. Valeria and Claudio Agüero, please turn the camera as soon as you can. Okay, let me change the camera, speaker view, and play my video. Let me erase the whiteboard. Don't worry about it. This is a ninth grade lesson. Today we're going to continue with actually a new lesson according to the problem, but with you guys will be a little review because we are studying this lesson last year in geometry, but obviously we're going to prepare a little review of that one. In the last class, we learned how to distinguish what will be the difference between the regular trigonometric ratios with their inverse. I mean, we learned how to calculate the 6 trigonometric ratios. In that situation, I'm talking about the ratios will be sine, cosine, tangent, and the opposite, that will be cosecant, secant, and cotangent. We learn how to identify the hypotenuse in the right triangle, obviously, and the legs, what will be the opposite and what will be the adjacent legs. Is solving right triangles and of course, their applications. Today, we're going to continue with the extension of the trigonometry of triangles, but instead to use the right triangle trigonometry, we're going to apply trigonometry of triangles with the angle that will be different at right angle. In this, when that cases happen, this is a oblique angle of triangles. The name of that situation we can apply is the love of sines and love of cosines. All right. Love of sines and cosines. This love are using with triangles when they're obviously they are not right triangles. Just for give you, let me give you an example, a little explanation. We have a single triangle with acute angles. Remember acute angles, all of them. We have three acute angles or at least one obtuse angle. Acute angles are angles that with their measure that's supposed to be less than 90 degrees, and obtuse angle is a one angle superior and 90 degrees. We have, for example, this triangle with three vertices. Vertex A, vertex B, and vertex C. For each vertex, we're going to label one single line of this angle using the Greek alphabet. For example, A, we have the angle alpha. B, the angle beta. And C, the angle gamma. All right, think about it. In this lab of sines and cosines, okay, this is another way of saying so knowing like the love of mirror because their legs, the name of the legs A, B, and C will be located just in front or the opposite position on their vertex. And simple merely words, the leg A will be located just in front of the vertex A. We have the vertex A over here. So the legs A will be located over here in front. The letter B, because we have the vertex B over here, the leg B will be located to the left side. This is another way of saying the law of the mirrors because it's the opposite. For that reason, the third leg will be located just in front in the vertex C. All right. That this kind of triangle works for both situations, the love of sines and love of cosines. But just for introduction, in the love of sines, we have two ways how we can use this singularity property. For example, if you're looking for the value from the angles, we can use this proportion. Sine alpha over 8 equals sine beta over B and sine gamma over C. And this is the lowest side you're going to find in, it doesn't matter what kind of textbook, will be the same. This is the universal. But think about it. What happened if instead you're looking for angles, you're looking for legs? Well, because we have a proportion, we can rewrite this law of sines in the opposite because the three are proportions. So for that reason, another way of saying to write this law of sines will be given by A over sine alpha equals B over sine beta equals C over sine gamma. And this is how, my dear students, we can calculate and interpret the law of sines. The first one, if you're looking for angles, and the another one, if you're looking for the legs. Remember, the name of the side of the triangles, we're talking, we are knowing like the legs. This is for one sample. But on the other hand, we're going to draw the same triangle because in this triangle, they are going to have the same behavior, right? We had three vertices. We're going to have the three angles, and the legs will be located in the opposite position, just like at the law of sines. There's not going to change at the beginning. So we got alpha, beta, gamma, and the name of the legs are the same. A over here, B over here, C over here. But in this situation, the question is how we're going to use the law of sines and how we're going to use the law of cosines. Well, the answer is simple. The law of sines will be useful if and only if we know at least two angles and one singular side, or two consecutive sides and one opposite angle. It's simple. But if you're having a hard time trying to remember how to use the law of cosines, well, you can try to remember what will be when we're going to use the law of sines. Sorry, we can try to remember when we have to use the law of cosines. In the law of cosines is easier to remind you because we have a one singular situation. Let me explain. The law of cosines can be used in two cases. Case number one, when we have a triangle triple side. What does that mean? When we know the three sides of the triangle, but we don't know what will be at least one singular angle. This is one way. And another way, to use the law of cosines, if and only if we have a triangle side angle side. What does that mean? That means when we have two sides in the middle between them, we know the angle. When that's happened, okay, in the second condition, we're going to apply the law of cosines, just like the hippie signal. Just in that was a popular sign in the 60 or 70 years, 70 years. So they'll say, yeah, this is peace and love, right? So in the law of cosines, you're going to know this side, we know this side, and the angle between them. So in that moment, that's happened. Okay, in that case, I'm going to use the law of cosines. Or the second one, when we have the three sides of the triangle, but we don't know what is the measure of the angles. If they're not accomplished, these two requirements, okay, what does that mean? We have to use the law of sines. And what will be the postulate of the law of cosines? Well, depending the vertex. For example, if we're looking for the leg A, the law of cosines given by the equation A squared plus B squared minus 2AB cosine alpha. This is going, if you are using, if and only if you're trying to looking for what will be the side A. Because if you see the angle between them, oh, sorry, this is C. C squared, B squared minus 2CB cosine alpha. Because if you see the picture, because we're looking for the value from A, the legs will be B and C. And the angle between them will be alpha. And this is going to be the general equation. What happened if instead of looking for the letter A will be the letter B? You're looking for the letter B. Okay, we got B squared. The involving legs will be A and C. This is the Hebrew signal. Remember, just in front, we got A squared plus C squared minus 2AC. Okay, 2AC cosine of one angle. What is the angle between A and C? The angle beta, right? So the angle between them. All right, let's see. If I have to looking for the C square, what will be the rule? Anyone? We are looking for C now. What will be the rule? What are the involving legs and what will be the angle? All right. Anyone?
You'd be looking for like you'd be using the leg B and A.
B and A. Okay. What will be the equation? Just follow the pattern. Please tell me what will be the equation.
B squared.
B is squared. Okay. B squared.
Plus A squared.
No, A squared. Minus 2 what?
BA cosine omega. What's the sign?
Cosine gamma. Gamma. So this is that, or if you wish, you can say you can arrange like a squared plus b squared minus 2ab cosine gamma. Remember the community property of the addition and the product. The order of the factors doesn't affect the final result. And this is the introduction how to use the law of sines and how to use the law of cosines. Okay, so. But I don't know, before to starting solving problems, do you have some questions or everything is clear until this part? No questions? In the class, anyone? In the classroom, anyone who has questions, doubts? Don't hesitate to let me know. You can use the microphone and please perform the question if you have some doubts. 11th grade class in the classroom. No one has a questions? Mrs. Sue, no one has a questions?
Dicen que no.
Okay. All right, so let's continue then. Let's go into solving the first example. I know, once again, this is just like a little review for you because we started this lesson last year in geometry. So the first example says, just for warming engines, right? Solve the triangle. Solve the triangle. When the problem mentions solve the triangle, that means we have to make sure to know what will be the measure of the three legs and what will be the measures of the three angles. All right. Let me draw the picture, the problem. Tu-tu-tu-tu-tu-tu. Mhm. Da-da-da-da-da-da. Excellent. All right. This triangle, it has three vertices, A, B, and C. A, B, and C. And they gave us angle like 20 degrees. This is 25 degrees. 25 degrees. And we got one known side will be 80.4. So in the problem says solve the triangle. Again, once again, when the problem says solve the triangle, that means make sure you know that the three legs of the triangle and obviously the three angles of the triangle. What will be the easier part in this situation? Solving by the angles. Remember, it doesn't matter what kind of triangles we're talking about. Obtuse, scalene, right triangle, isosceles, the addition of the internal angles of any triangle that will be equal 180 degrees. So the name of the missing angle, in this case, that will be beta because it's located in the vertex B. Okay, but if you want to label like a theta or gamma, epsilon, actually the name of the angle, it doesn't matter. That is matters, you can apply the right process. So remember the postulate. The addition internal angles for any triangle that will be equal 180 degrees. So beta plus 20 plus 25, that will be equal 180 degrees. Solving for beta will be equal to 180 degrees subtracting 45. And this is going to be 135, right? 135 degrees. This is the solution for the angle beta. Well, if you wish, instead of looking for beta, let me copy over here. Beta equals 135 degrees. Okay, we got the three angles. Now we have to looking for the missing sides. What are the missing sides? What is the name of this leg? A, B, or C? The distance between B and C, what is the name of the leg? Anyone?
A.
A, because remember what did I tell you? The name of the legs will be labeled like the opposite their vertex. So A is going to be the leg A, and obviously this is going to be the leg B in 80.4 because it's a known variable. It's a known value, sorry. This is going to be the leg C. So which side would you like to find first, 8 or B? Which one would you like to find first, 8 or B?
A.
All right, 8. So this is the useful strategy that I'm telling you. Obviously, they're going to apply the law of sines because we know the triangles and we know the sides, right? So instead to use the original proportion, we can use the second one because the second one are designed to looking for the legs. So according from the proportion, I'm going to divide 8 over sine of what? Sine alpha. And alpha will be 20 degrees. Remember the opposite equals, obviously the leg I'm going to use will be the C because I know what is the value, 80.4 over what? Over sine 25 degrees. And because we're looking for the leg A, okay, A that will be equal to 80.4 multiplied by sine of 20 divided by sine of 25 degrees. And this is how we're going to solve by the leg A. Remember, because in the physics class, my dear students, we are changing the regular setup, the calculated to degrees to radians. Remember, before to use the lava signs and cosines, make sure your calculator must be set up in degrees. In the, in the letter D. In the letter D, your calculator. So let's begin. We got 80.4 sine 20. And this answer divided by sine 25. Well, we got 65.07. 65.07. Okay. We finally found the leg A. Now let's going to find the leg B. Remember the leg B? B over sine of what? The angle in front of B, 135 degrees. Okay. Equals what proportion? Well, simple. You can use the same proportion to looking for A, or if you wish, you can use the proportion 65.00 or sine of 20. It doesn't matter which one would you like to use. At the end, the result will be the same. But to avoid any confusions, we can use the first proportion that we used to find the letter A. 8.4 over a sine of 25. And repeat the process. Solving for B, we got 80.4 sine 135 degrees over sine of 25 degrees, and B will be equal to 80.5 sine 135 divided by sine 25, and we got 134.52. And we got the solution set for this problem. Every time that our problem mentioned solve the triangle, that means we make sure to know what will be the measure of the three legs and what will be the measure of the three angles. Let me change the in this marker to place down with this refraction. Okay, questions? Remember, make sure your calculator must be set up in radian, in degrees, no in radians. I'm telling you because actually 10 years ago, I have a good student. He made the excellent exam, but he made that mistake. He totally forgot to change the calculator to radians into degrees. That was a fun experience. Yeah. Yeah, but he's crying now, Mister. What happened? This I made a mistake. What? This is like the meme when the bridge, when the engineer construct the bridge, it says, and the bridge is falling down, and and the joke says, what happened? Well, it happens the calculator was in radians mode. Well, same happened over here. If you're set out the calculator in radians and using the values in the radians, obviously the answers will be different, right? So that's why I'm giving you once again the advice. Make sure the calculator must be set off in radians. Okay. Okay, let's do another example. The real ones. The example number 2. Okay. And we have a word problem. So the problem says a satellite orbiting the Earth orbiting the Earth. Let me increase the zoom on this one. Passes directly overhead. All right. A satellite orbiting the Earth passes directly overhead at observation stations. At observation stations. Observation stations in Phoenix. In Phoenix and Los Angeles. In Los Angeles. Period. Sorry, comma. 340 miles apart. Okay, apart. Period. At an instant, instant, at an instant when the satellite is between when the satellite is between um, these two stations, um, its angle of elevation its angle of elevation, it simultaneously observed to be observed to be 60 degrees at Phoenix, 60 degrees at Phoenix, and 75 degrees at Los Angeles. All right. The question is, how far is the satellite how far is the satellite from Los Angeles? Okay. In this situation, I mean, you can treat this problem like a physics. Ay, Dios santo, perdón. Okay. Good idea will be create a free body diagram or imagine what the problem happens. So remember, we're talking about a satellite. Okay, let's going to draw the picture of the satellite. This is a satellite. All right, this is a satellite orbiting the Earth and passes directly overhead at observation stations in Phoenix and Los Angeles, 300 miles apart. So we have a one singular station over here and another one. All right. One of them, obviously, we can call this one Okay, let's go into label like P, the Phoenix, LA, Los Angeles, and S, that will be the satellite. Okay. According for the problem, there's a separation between these the observation stations in Phoenix, Los Angeles, 300 miles apart. So we can draw, if you wish, a dash line between these two things. And remember that problem mentioned, they had a distance of 300 miles apart. Okay. Now, at instance, when the satellites is between these two stations, the angle of elevation, what does that mean, angle of elevation? Angle of elevation means when you move your head forward to see one single objective. So the two observation stations, they're looking for the satellites. One over here and the other one over here. All right. The first one in Phoenix, 60 degrees in Phoenix. Okay. 60 degrees in Phoenix. And by the other hand, that will be 75 degrees to Los Angeles. Okay. So the question is, how far is the satellite from Los Angeles? So in this case, they're probably asking for only this letter X. Or if you wish, you can put like a P side or I don't know, just the label. It doesn't matter. That doesn't matter. You can create a picture of the situation. So as soon as you can see, we know at least two angles, and we know obviously we don't know what is will be the one side. So there's no way we can use the law of cosines, right? Because to use the law of cosines, we're supposed to use that triangles, side angle, side. I remember two sides in between them. We're supposed to have an angle, or we have the three legs. We don't know any angle, but this is not the case. Before to start the problem, we can perfectly looking for what will be the third angle. This angle, you can label that like a theta, for example, if you wish. No request in the problem, but at the moment you're going to create the proportion, this angle theta will be useful to find out what will be the distance x. Remember, postulate, it doesn't matter what kind of triangle we have, the addition of the internal angles, that will be 180 degrees. All right, so theta will be 180 minus 135. All right, for that reason, this is going to be 45 degrees. Okay, this is going to be the angle theta. All right, theta equals 45 degrees. Okay, and because we're looking for what will be the leg x, the leg x is simple. We're going to create the proportion, applying the level sign, but instead to use the proportion from the angles, we can use the proportion from their legs. So remember, x will be divided by sine of what? The angle just in front of the letter x. X over sine of 60 degrees, okay? That will be equal to, obviously, the known length, that will be 340 miles, divided by sine of 45 degrees. So simple merely words, x will be equal to 340 miles times sine 60 degrees divided by sine of 45 degrees in x, that will be in a value of 340 sine 60 divided by sine 45. So the answer will be 416.41 miles. And this is going to be the solution set from the problem number 2. Questions? Preguntas, preguntosas, alguien que diga algo, comentarios, quedó todo claro, todo azul, mis estimados. Obviously, tomorrow I'm going to continue solving more problems, okay? I don't know if in the in the classroom is anyone who has questions? No questions? All right. So I sent the picture in the WhatsApp group already. Thank you so much for your attendance because there's not much time. We're 2 minutes left. So see you tomorrow in God wills. Thank you so much. Take care of yourself.
Thank you, Mr. Zio. Tomorrow.
Bye bye.
Hi, Mr.
Thank you.
Bye bye.
Hi, Mr.
Salon.
Have a great day. Take care.
Have a good day too. Take care of yourself.
See you tomorrow.
See you tomorrow. See ya. So, lots. Adiós. Bueno, mucho gusto. ¿Se miró bien se mira bien la imagen, muchachos? Eso me olvidó preguntarles. Ok, perfecto. Cuídense. Nos vemos. No entendí, pero bueno, adiós. Sí, ok, ya lo mandé, no se preocupe, ya lo mandé por el grupo de WhatsApp también, no se preocupe. Vaya, pues.